Welcome. So this question says a 2 kilogram block is stationary on an inclined frictional surface. What is its frictional force? So here again we are going to visualize the situation. We have the incline. We try to make the angle pretty good. I think less than 45 degrees or greater than 45 degrees is really important. And this is 20 newtons because it's a 2 kilogram mass. And then, as we've said before, we break up the reaction force into two components. And we have the F normal, which is the component of the reaction force that's perpendicular to the surface. And we have the frictional force, which is the component that's along the surface. And in this example, we want to find the frictional force. And so we'd like to be able to solve this in one step. And what we're practicing in these last few questions is being careful about how we pick the axis that we choose to resolve our forces along. Because if I only want to deal with the frictional force, then I don't want to deal with a normal force. And if I don't want to deal with a normal force, I need to pick an axis of interest that is perpendicular to the normal force. This happens to be along the slope, but the key thing is it is perpendicular to the normal force. It's perpendicular to the thing that I don't want to deal with. Sorry, my pen just erased what I'd drawn. So, okay. Now I need to go to the next step, which is to visualize the forces along that line. Fn has no components along that line. Ff is itself lying on that line, so the component of Fn along the line is Fn, and I can visualize this down the slope component. And I'm hoping you get into the stage where you can look at that and you can go that say that this is 20 sine 30 newtons. And my logic behind that is if this is 30 degrees, then this over here is 60 degrees because it's part of a triangle. And then if that is 60 degrees, this is 30 degrees down here because this is also part of a triangle, a different triangle, but nevertheless a triangle. And now I have an opposite and a hypotenuse as part of a right triangle, and so opposite over hypotenuse equals sine. So that's where I get that from. I hope that gets easier and easier for you. And so the next thing to do is to solve this thing. So I'm going to say find F using the sum of the forces along, let's say, the red line. So red line equals 0. My red line needs a positive end and a negative end, so let's call this end positive and this end negative. It doesn't matter which one I do as long as I'm consistent with how I treat the problem from then on. And so I can say, oh, in that case then positive FF added to negative 20 sine 30 equals 0. So FF is equal to 20 sine 30. So FF is equal to 20 sine 30 is actually 10 newtons. So FF is equal to 10 newtons. I can put that in a nice little box. And there it is. By the way, let's not forget straightforward vector diagrams. So here is my weight, and I know that this is 20. Now normally I'd be doing this with a ruler and a pencil, but I can't do that on the computer screen. I'm sorry. But you can get the idea from it. And then I have this force FF. I'm looking at my 3 original vectors. My 20 newtons was pointed vertically downwards, and I can measure how long that is. That's 20 centimeters, or that's 10 centimeters, whatever. And then I don't know the length, I don't know the size of FF, but I do know its direction. I know its direction is inclined to the horizontal at 30 degrees. So just draw a long line at 30 degrees. And I don't know the length of Fn, but I do know its direction. And I know that it is inclined, to the horizontal at an angle of 60 degrees. Ooh, let's get this 60 degrees. These two have, sorry about my pen. So these two meet at 90 degrees, and they meet here. So this means that because my FF goes up and to the right, there's my FN, sorry, my FF, and because my FN goes up and to the left, let's do this in blue to keep my colors. I'm sorry, it's much better with a ruler. Sorry, but there's FN, FN. This is FF. And so with the scale, 1 centimeter equals 1 Newton, I can measure this length and see how many centimeters it would be. And frankly, it would be 10 centimeters. If it was 10 centimeters equals 20 Newton, then this would be 5 centimeters long, and it would mean it's 10 newtons. But this diagram will give us a quite decent value, and I think it's quite accessible, it's speedy. It may be that you use this to check your numerical value over here, or in some cases, you could just simply use a vector diagram to get a decent answer. Either way, the answer is 10 newtons. And there we have it.